For amines. Amines are derivatives of ammonia in which one or more hydrogen atoms are replaced by alkyl or aryl groups. When one of these three hydrogen atoms is replaced by alkyl or aryl group, primary amine is formed. When two of the three hydrogen atoms are replaced by alkyl or aryl group, secondary amine is formed. When all the three hydrogen atoms are replaced by alkyl or aryl substituents, tertiary amine is formed. Nicotine present in tobacco leaves and caffeine present in seeds of coffee plants are amine-containing compounds. Our aim here is to identify amines using some simple tests. They are Solubility Test, Litmus Test, Azo-dye Test, Nitrous acid Test, Hinsberg Test. Solubility Test. Materials required: organic compound, dilute hydrochloric acid and dropper. Procedure: take a small quantity of dilute hydrochloric acid using the dropper. Add it to the test tube containing organic compound. Shake the test tube well. Amines have appreciable basicity, so they dissolve in mineral acids. Litmus test. Materials required: organic compound, moist red litmus paper and dropper. Procedure: take a small quantity of organic compound using a dropper. Put 1 or 2 drops of the compound onto the moist red litmus paper. Amines turn red litmus blue, indicating it is basic in nature. Azo-dye Test. Materials required: organic compound, sodium nitrite, beta-naphthol, distilled water, dilute hydrochloric acid, dilute sodium hydroxide, ice-cold water, test tubes and droppers. Procedure: take small quantities of organic compound, sodium nitrite and beta-naphthol in test tubes A, B and C respectively. Using a dropper, add a small quantity of dilute hydrochloric acid to test tube A. Shake the test tube well to dissolve the compound in hydrochloric acid. Now, add a small quantity of distilled water to test tube B. Shake the test tube well to dissolve sodium nitrite in distilled water to get sodium nitrite solution. Using another dropper, add a small quantity of dilute sodium hydroxide solution to test tube C. Shake the test tube well to dissolve beta-naphthol in dilute sodium hydroxide solution. Cool the test tubes in a beaker containing ice-cold water for some time. Now, add sodium nitrite solution to the organic compound. Primary amine on reaction with nitrous acid formed from sodium nitrite and hydrochloric acid gives diazonium salt. Then, add the resulting solution to test tube C containing beta-naphthol solution. The diazonium salt undergoes coupling reaction with beta-naphthol to form a scarlet red colored compound called azo-dye. Nitrous acid test. Materials required: primary, secondary and tertiary amines, sodium nitrite, distilled water, concentrated hydrochloric acid, ice-cold water, test tubes, droppers and spatula. Procedure: take small quantities of primary, secondary and tertiary amines in test tubes A, B and C respectively. Using a spatula, take a small quantity of sodium nitrite in a test tube. To this, add a small quantity of distilled water. Shake the test tube well to dissolve sodium nitrite in distilled water to get sodium nitrite solution. Cool the solution in ice-cold water for some time. Now, using a dropper, add a small quantity of concentrated hydrochloric acid to test tubes A, B and C. Shake the test tubes well to dissolve the compounds in concentrated hydrochloric acid. Cool the test tubes in ice-cold water for some time. Now, add sodium nitrite solution to test tubes A, B and C. In test tube A, primary aliphatic amine reacts with nitrous acid formed from sodium nitrite and hydrochloric acid to produce nitrogen gas, which is seen as bubbles. In test tube B, secondary amine reacts with nitrous acid to form a yellow oily layer of nitrosamine. In test tube C, tertiary amine reacts with nitrous acid to form soluble nitrite salts. Hinsberg test. Materials required: primary, secondary and tertiary amines, 25% sodium hydroxide solution, distilled water, benzene sulfonyl chloride, concentrated hydrochloric acid, water in a beaker, test tubes and droppers. Procedure: take small quantities of primary, secondary and tertiary amines in test tubes A, B and C respectively. Using a dropper, add a small quantity of 25% sodium hydroxide solution to test tubes A, B and C. Now, add a small quantity of distilled water to each test tube. Using another dropper, add a small quantity of benzene sulfonyl chloride solution to each test tube. Shake the mixture in each test tube for some time. Cool the test tubes in a beaker containing water. Primary amine reacts with sodium hydroxide and benzene sulfonyl chloride to form soluble sulfonamide salt. Secondary amine reacts with sodium hydroxide and benzene sulfonyl chloride to form insoluble sulfonamide. Tertiary amine will not react with benzene sulfonyl chloride, but it is insoluble in sodium hydroxide. Using a dropper, add a small quantity of concentrated hydrochloric acid to test tube A. Soluble sulfonamide salt formed will react with hydrochloric acid to form insoluble sulfonamide. Now, add a small quantity of concentrated hydrochloric acid to test tube B. The insoluble sulfonamide formed in test tube B will not react with hydrochloric acid. Finally, add a small quantity of concentrated hydrochloric acid to test tube C. The insoluble amine reacts with hydrochloric acid to form soluble ammonium salt. Precautions: handle the organic compound with proper care. Handle hydrochloric acid with proper care because it is highly hazardous.